Okay, I have figured out a way to do these quartiles much easier with Excel. And as I explained before, Excel is key to passing statistics. So here's your data, all right, 15 data points. The first thing you do is type in the data points. You do not have to type them in an order, okay? So that's the nice thing. Just type it down or type them in as they come in. So then to get the first quarter, Q1, you go to Formulas, you go to More Functions, you go to Statistical, and you go to Quartile. Pretty sure it's this one, okay? Then you click on the array, all right? And then you type in the quartile. It's either going to be 1, 2, or 3. Quartile 1, okay? And so your first quartile is 2.1, all right? So in other words, 2.1, if you put them in order, 25% of the data is less than 2.1 is what that means by first quartile, in case you didn't grasp that so far. All right, the third quartile, you do the same exact thing, except you just hit 3 when it comes to, I'm going to just type this in. You could type in anything you want just to, you keep them. So just call this Q1. Let's just do that. All right, so you always have to pick a spot outside of this data or it's going to really get screwed up. So I'll go ahead and label this Q3 if you want, so you know what you're finding. All right, so then go to Formulas, More Functions, Statistical. Very simple. This will save you a lot of headaches, a lot of time. I'm trying to talk and do this at the same time, and sometimes I'm not very good at it. Okay, so array, all right, quartile 3, and there is Q3. So in other words, what this means, again, if you put these all in order, then 75% of the data will be less than 3.5, and 25% of the data will be more than 3.5, okay? Now let's go to Q2, which is the same thing as the median. Q2 is the same thing as a median, which means if you put them in order from lowest to highest, half will be less and half will be more, okay? And again, the same thing, formula, more functions, statistical, quartile array, and 2. And so there's the median. Again, half more, half less. And then it did ask you for the mean also. The mean is the same thing as the average, so I'll just put mean / average. All right? And you should know how to do this by now, but just in case you don't, formulas, more functions, statistical, average. And again, highlight those, and that's all you need to do. So 2.91333 is the mean or the average. That means if you add all these up and divide by 15, you'll get 2.9. So if these were test scores, then 2.9 was the average score for the class, all right? And the mode is simply what number appears the most, and looks like 3.2 appears the most. There's one of them, there's 2 of them. It's the only one that appears more than once, so the mode is 3.2, all right? The range is simply the highest minus the lowest, so find the highest and find the lowest and subtract the one from the other. The interquartile range is the Q3 minus Q1, so IQR equals Q3 minus Q1, all right? So, and then so if I could do it in Excel or on my calculator, I'm just going to do it in Excel. When you do it in Excel, you hit equals Q3 minus Q1. Okay, 1.4. Okay, 1.4. And then the outliers, again, when you do the outliers, for the lower outlier, you just have to do this on the calculator. I don't know if there's a way to do it in Excel, but it's easy. Is equal to the Q1 minus 1.5 times the IQR, and the upper outlier is equal to Q3 plus 1.5 times the IQR. Okay, so what that means is, so the IQR is 1.4 right here. You know Q1 is here. So this one would be equal to, so I type it out so you could see it. So it would be 2.1 minus 1.5 times 1.4. And if I do that on my calculator, I'll just do that on my calculator. And that will equal 2.5 minus 1.5 times 1.4, 0.56. Okay, and the upper outlier is going to be Q3 plus 1.5 times that. So Q3 is 3.5 plus 1.5 times 1.4. So that answer on my calculator is 3.5 plus 1.5 times 1.4 equals 5.6. Okay, so what that means is this. If there's any data that is less than 0.56, it's considered an outlier. Okay, there is no data that's considered that is less than 0.56, and the same goes for any data that's higher than 5.6. There is no data that's higher than 5.6. So in other words, there are no numbers in the data sequence that is considered to be an outlier. And an outlier, in case you're not sure what outlier means, it doesn't stand out as extremely high or extremely low compared to the rest of the data. Okay, so in other words, if I had a 7.2 as one of the data points here, that would be considered an outlier. That would be considered much higher than the accumulation of the rest of the data. Okay, but in this case there are none. So there are no outliers. Everything is pretty much somewhat close together. Okay, I hope this helps.